Am I audible? Am I audible, students? Yes or no? Am I audible?
Yes, ma'am.
Please mention in the chat box whether I am audible or not.
Yes, ma'am. I can
Okay.
hear you.
Okay. Thank you for the response. Okay. So, last class we have done the discussed about the geological work of your atmosphere, right? Atmosphere we have done, and the geological work of wind also we have done. So today we will be discussing the geological work of water. Okay. So before coming to the the works of streams and rivers, so before coming to that, before coming to the terminologies, so let me first tell something about the introduction part. So basically, what happens is that our Earth, it is the surface of our Earth. It is basically covered with almost, you can say, 70% of water. Okay, so 70% of water it is covered in the form of what? In the form of your streams, or it can be lakes or rivers or seas or oceans. Okay, so all these things it comprises of like 70% of the water it is comprising. Okay, so this this water when it is in motion. Okay, so when it is in a liquid form or it is in motion, so it proves to be the most important geological agent, and that modifies the surface morphology. Okay, so this is the background of your geological work of water. So water is it proves to be a most important geological agent of this surface in modifying the surface morphology. So we have some like the running water, it is considered as the most again powerful agent, okay, of all this changes. Okay, so the running water is in motion, so it is considered as the most powerful natural geological agent, you can say, geological agent of the change. So what is happening here is that the small surface bodies of water that is flowing in channels. Okay, so these are known as your streams, or also you can say it is known as your streamlets. Okay, so again, these streams, when they are flowing in a very big area, and they are ultimately they are joining a single channel. Okay, a single channel. So and this take the shape of a river. Okay, so ultimately river is formed by many small streams. So, what are actually the sources of stream water? So, there are three sources of stream water. So, number one is a runoff. So, what is a runoff actually? The part of the precipitation. Okay, it is continuing. Like flowing over and above the surface of the earth. Through the channels. Okay. So this is termed as your runoff, and it makes a very big source of water for these streams and these rivers. Okay, so whatever part of precipitation it is flowing above the surface of the earth, okay, over and above the surface of the earth, so that is your runoff. Okay, then comes your subsurface water. So this part of this precipitation, this is somewhat, some part of this precipitation is absorbed by the soil and the rocks. Okay, and then after the soil voids are filled up, so what happens is that these, part of the precipitation, it, goes below the surface of the earth. Okay, so some part of the precipitation it is absorbed by the soils and these rocks, and the other part of it goes below the surface of the earth. So whatever water has infiltrated into this earth, okay, it is known as your subsurface water. Okay, the next is your glacial meltwater. So this glacial meltwater, it is, you can say, a third source of water for these, rivers and streams, and ultimately it forms a glacier. These glaciers, they, undergo melting some regular processes, and also, they melt at the top of, during the summers also, they melt. So these glacial meltwaters, they contribute a lot to the, to the total volume of these mountainous streams. Okay, so these three are the sources of your stream water. So next is your, how actually, what are the methods of your this river erosion. So the streams and these rivers, as you know, these are the most powerful, subaerial agents of this erosion. So the running water, this performs its erosive work in some different ways. So these are like hydraulic action. First one is hydraulic action. Then comes your cavitation. Then abrasion is there. Then attrition is there. And corrosion is there, like that. Okay. So first one is your hydraulic action. So hydraulic action, you can say that it is the loosening and this removal of the materials from the rocks. Okay, these are the it is a mechanical process, and it is the loosening and removal of the material from the rocks, and this is happening due to the pressure that is, exerted by the running water. So if the velocity is very high, and if the velocity is high, then what will happen? The pressure will also be high. The pressure of this running water, it will also be high, and ultimately what will happen, that it's the capacity to, the move out the parts of the rock, it will also be very great. Okay, so this is your, about your hydraulic action. So it is the, loosening and removal of the materials that is from the rocks, and it is happening due to pressure that is exerted by this running water. Then comes your cavitation. So cavitation, you can say that this is a type of it is a very rare type of hydraulic action that is performed by this running water, and it is particularly observed, where this river water, it suddenly acquires some very sudden high velocity it acquires, such as, in case of a waterfall. For example, you can say, in case of a waterfall where the water, it suddenly acquires a very high velocity. Okay, suddenly it acquires a very high velocity. So again, if it is suppose, in other words, you can say that there is a very, spontaneous change in case of those situations. Thus there is a very spontaneous change from a liquid to, either it from a liquid to a vapor state, or again from back to a liquid state. So these type of changes, okay, in it results in what? It results in sucking out the material, and thereby it is creating some holes and depressions, with the passage of time. So that is your, it is creating some, depressions and these holes. So this is known as your cavitation. Okay, so next one is your abrasion. So abrasion, you can say that it is a very, principal method of this stream erosion, and this is involving, the wearing away of these bedrocks and also these rocks. Okay, and these bedrocks and rocks, these are along the banks of a river, and this is the wearing away of these rocks, by this running water, and with the help of what? With the help of some sand grains or pebbles and gravels also, you can say. And these particles, they are carried by its load. These are carried by it as a load. Okay, so these particles, or these grains or these fragments, they are moving along with this water, and these are known as like tools of erosion. Tools of erosion also, you can say. So this is about your abrasion. Then comes your attrition. So attrition also, you can say that this is a somewhat kind of this is the wear and tear of these load sediments, okay, being transported by this natural agency, okay, through like the process of some collisions is happening when they are being carried. So they are, subjected to some collisions, okay, which they suffer during their transport. So as a result of these collisions, this wear and tear of these load sediments are happening. Okay, so this is your about your attrition. Then comes your last one is corrosion. So corrosion, basically it is a very slow and a steady process of chemical action of this stream water, or especially you can say about the solvent. And it is this extent of corrosion, you can say that it depends upon the composition of the rocks and also on the composition of this where flowing water. So how much of corrosion will happen, that will depend upon the composition of rocks and also on the composition of the flowing water. So this is about the methods of this river erosion. So next comes your features of the stream erosion. So what is happening is that, this erosion, if it is happening for a very long time, okay, so this prolonged erosion by any this river or any of these associated streams, so they produces, many important surface features. And also with the passage of time, what happens, these form some, geomorphological landforms it forms, okay. So these are potholes, river valleys, these are some of the geomorphological landforms also, you can say, or some of the surface features that are, happening due to the prolonged this stream erosion. So these potholes, basically potholes, you can say that these are, very different various shaped depressions. These are kind of depressions of various shapes, okay, and of different dimensions. So they are developed in the river bed. Okay, they are developed in the riverbed by your erosion of these streams. And these potholes, they can be of any cylindrical, or this can be of bowl type shape in outline, and they can be of many meters in diameters. Okay, they can be of many meters. So these potholes, they are commonly, formed in the softer rocks. They are occurring in the softer rocks, occurring in the at the critical location in a bedrock. So this is about your potholes. Then comes your river valleys. So river valley, you can say that this valley, it can be defined as some of like of a lowland that is surrounded on sides by some inclined hills and or some inclined slopes and mountains. Okay, so it is a kind of a lowland surrounded by all those inclined hill slopes and these mountains. So every river, it is associated with a valley of its own. Okay, and in fact these are responsible for the origin, or these are responsible for the development, or you can say modification of your valleys through, the process of this river erosion. So this is about your river valleys. Then comes your next one is your waterfalls. So these waterfalls, you can define it like it is a jump, you can say. Okay, it is a magnificent. It is a jump that is, made by this river water at some specific parts of their course, and this is a very sudden, and this it is causing some considerable drop in this gradient. Okay, there is a sudden and a very considerable drop in the gradient of the channel. So these in this waterfall, what is happening, the stream, it literally falls from a very considerable height. Okay, before before it acquires a normal flow at the lower level. So it is falling from a very considerable height before it falls to a lower level. Then this velocity of this water at this point of fall, it also increases tremendously. And this height of this waterfall, it is also greatly, it is varying greatly to many meters. You have, obviously everyone has seen waterfalls. So this basically this waterfalls, you can define it is define it as your some magnificent jumps that this stream or these rivers are making at specific parts of their course. Okay, then comes your stream terraces. So this stream terraces, you can define it. Suppose it's like a very suppose a bench like surfaces that occurs on the these sides of many river valleys. Okay, so these are type of some bench like surfaces. So they are occurring in the sides of these river valleys. And if you see from a very distance, okay, far distance, then they will appear like several steps of these big natural staircases, okay, rising from this river bank. So these stream terraces, they can be made up of this hard rock or soft rock also. But the main thing is that they look like steps. Okay, so that is your stream terraces. Now coming to your river meandering. So river meandering, uh, you can say that this is like when a stream, it like flows along a very curved or zigzag path, and that acquires a loop shaped course. Okay, so it is said to meander. So it is this river when it you have everybody in you have seen a river, so it flows the stream, it flows like a very curved zigzag or this loop shaped course. So it is known as your meander. And these process of this development of this zigzag type of channel, it is known as your river meandering. So these meanders, these are these are developed mostly in the, you can say, in the middle and these lower reaches of these major streams. Okay, where these erosion, lateral erosions and these depositions are happening. Okay, so this is basically, you will remember this meander as like it is a curved or zigzag path. This is acquiring a loop shaped course. Okay, so it is this stream, it is flowing in a zigzag path. So that's the process of the the process of this development of this zigzag path type of channel, it is known as your river meandering. Okay, so this was about your geological work of water. So uh, next we come to the structural features of rocks. So structural features of rocks. Before that, let me give you the um, attendance link. Okay, you can fill it up till then. Okay, I hope everyone has got the link in the chat box. Till then, you please fill up this link for your attendance. Okay, so now coming to the structural features of rock. So the geological working part is finished for your water, wind, and your atmosphere. Okay. So now coming to the structural features of rocks. So before coming to the terminologies, these rocks, these are which are formed either on the surface of the earth or within the surface of the earth. They are subjected to numerous internal and external forces, where this might be either during their formation or either after their formation. Okay, so these rocks are every day these are, subjected to a large number of these external or internal forces. So the interaction of these forces with the rocks, it is, responsible for a variety of characters that is developed in these rocks. So like, you can, it is like a common observation that these rocks, they exhibit everywhere, different type of characters, or you can say features, or this disposition. So either in case, this in the case of this rocks, in some cases what is happening that these rocks, they can occur either in the form of some layers. Okay, layers which are, spread over some considerable areas, and it can be either horizontal also, it can be either inclined also at some different angles. Again, in different cases, you can say that the disposition, that is your the horizontal and the inclined rocks, it is also another type of structural feature. And in some other cases also of rock bodies, what is happening, where the rock bodies can be either horizontal or inclined, or it can be either, it is bending, or it is fracturing, or it is showing some displacement of blocks. So all these are, if you group together all these things, so these are known as your structural features of your rock. Okay, so if I say that what is a structural geology, then you can say that the, branch of geology that deals with the morphology, or the classification, or the mechanism, and this just a minute, no longer accepting responses. Is the form, it is not accepting responses, or what? Are you able to give the attendance? Let
Yes,
me check.
ma'am.
It's okay, right? So this student, he is saying that, yes, yes, your attendances are coming. Okay. So uh, I was talking about the structural geology. So this structural geology, you can define it as, suppose it is the branch of geology that deals with the morphology, or this classification, or this mechanism, and the, what are the causes of this development of this rock structure. So all this dealing with these things, it is known as your structural geology. Now coming to some of the terminologies that we have to know while studying the, structural features of this rock. So number one is known as, it is known as outcrop. So what is outcrop? Actually, these solid rocks, these are uh, not exposed everywhere on the surface of the earth. So these are mostly, these solid rocks are mostly covered with a very thick or a very thin type of loose deposit, which is known as our soil. Okay, so in some areas, what is happening, the soil, it may be spread over many kilometers, and this bedrock, it may not be visible anyhow. Okay, so in these areas, so however, in these mountains and in these submountaneous regions, so these exposures of rocks, it can be seen easily, and it can be forming at the sides of the valleys of these hills. So outcrop in general, you can define it as like, it is an exposure of a solid rock on the surface of the earth. Okay, so next one is your bedding or stratification. So like, most of the sedimentary rocks, these are deposited under conditions which are, which favor development of some distinct layers. These are piled up one above the another. So from these are distinct, these are piled up from one above the other, from top to bottom also, these are piled up. So these layers, these are called beds, and or also you can say these are called as strata, or stratum also you can say. And these are quite often distinguishable, like you can distinguish it on the basis of color, or composition, or grain size. So this layered character, it is called your bedding or stratification, and also it is one of the most fundamental structures of these sedimentary rocks. Okay, then another term comes under this bedding or stratification, that is your lamination. So this lamination, it is a very similar term related to stratification. So it means that these are extremely fine grained sedimentary rocks, which are made up of clay or silt, and they are, you know they have different layers, and these layers are very thin, and so much thin that it is paper thin, okay, like a paper, so it is thin like that. So this is known as your lamination. So next comes your dip and strike. Okay, dip and strike. So while studying rocks, we generally speak about the attitude of rocks, or their outcrops. Okay, so this attitude is, it is simply known as their disposition in this space, or the way in which they are exposed at a place. So, and also which can be, it can be expressed in some geographic terms also, it can be expressed. So this deep and strike, so these are two basic quantities which are used to express the altitude of any rock body. Okay, and the deep, it is defined as the angle of inclination of a layer of rock with the horizontal. So this one, it is expressed both in terms of degree of inclination also, and also in the direction of inclination also. Okay, so in this your uh, picture, you can see this is a type of a rock body. So here, this is the direction of your dip. Okay, so and strike, on the other hand, this strike, it is a geographic direction, okay, in which this line of intersection of a horizontal plane with a bedding plane of a layer rock. So this strike, it is the opposite to the dip direction. Okay, so this is a strike direction. You can see this is a strike direction, and this is a dip direction. Okay, and this strike and dip, they are always perpendicular to each other on the map. So next is your, like, this, what are the different types of dips. Okay, so there are two types of dips. So that is your apparent and true dip. Okay, not this one is also a type of dip, and another type of dips are also there. So the first one, the important one, is your apparent and true dip. So this apparent dip, you can say that like when the dip of a layer, it is measured in the direction that is essentially at right angles to the strike of that particular layer, so it is called your true dip. So this true dip, it is your the deep layer, or the dip of this layer, this is in a direction at right angles to that of the strike layer. Okay, and this your the what is the apparent dip. So the dip of this layer, when it is measured in any other direction and which is not at right angles, that is known as your apparent dip. Okay, and this true dip and apparent dip, it has a following relation, which is your tan alpha is equal to tan beta into cos gamma. So where alpha, it is your apparent dip angle, beta is your angle of true dip, and gamma is your angle between the strike and the direction in which the apparent dip is measured. So this is about your apparent and your true dip. Now coming to the types of dip. So that is your it can be this dip, it can be measured over a very large area, and it may be of any original feature. So these are again distinguished into the following types. So that is your primary dip, secondary dip, local dip, and regional dip. Okay, so primary dip, it is like when these sedimentary rocks, these are deposited in a sloping basin. Okay, they are inclined also in the same fashion. So if this original slope of the basin, it is between 5 to 10 degrees, 10 degrees, then this sedimentary formations accumulating over there. So over this period of time, so it will also have the same disposition. So such dips are called as your primary dips. So next is your secondary dip. So secondary dip is like if the inclination angle induced in the strata after its deposition due to the tectonic forces to which strata have been subsequently subjected. So what is happening here is that secondary dips, they may range in value up to some vertical. So in fact, such forces, it may even cause this overturning and inversion of this strata. Okay, so this secondary dip, it is basically, it is the inclination that is in the strata, that is after the disposition due to all these tectonic forces. So next is your local and this regional dip. So local dips are inclinations of the rocks exposed in a limited area of observation. So this local dip and regional dip are just opposite to each other. So this local dips, these are inclinations of these rocks that are only in a very limited area of observation. And this regional dip, it is just the opposite, that it is an inclination of the series of formations, and these are over a widespread area. Okay, so this is about your types of dips. Then comes your okay outcrop dimension. Okay, then comes your outcrop dimension. That is, these outcrop dimensions, outcrop we have studied. So dimensions means we have to study about, we have to know about the width or the thickness or the depth. Okay, so this width of this, or the width or this breadth of this outcrop, it is given by the distance between the top and bottom edges of the bed. Okay, the distance between this top and the bottom edges of the bed, it is measured on the surface of the ground in a you have to keep the direction in a perpendicular to strike of that particular bed. Okay, so that is your thickness, sorry, that is your width. Okay, next is your thickness. So thickness is, it is, you can say that it is of a perpendicular distance. It is a perpendicular distance between the top and bottom surface of this same layer. Okay, so for the same layer of rock, the perpendicular, which is the perpendicular distance between the top and the bottom surface, so that is your thickness. And depth it is, you can say it is a it is at any place from the surface, and it is believed to be, it is given by the perpendicular distance between the ground surface and the top surface of the particular layer. So it is a perpendicular distance between the ground surface and the top surface of the particular layer. So there is also a this relation between the depth of this bedrock and about this angle of this true dip. So this is the formula. You can see that D is equal to AC into 10B. So where this uh, this D is the angle of this true dip. Okay, and B it is, and C it is a distance from the exposure to the place C. Okay, so you can remember this formula, the outcrop dimension, thickness, width, and depth relation. Okay, so next comes your one part, that is your fold and folding. So these folds, okay, these you can say that these are defined. You can define it as the undulations or the bends, or also the curvatures. It is a that are developed in the rocks of the crust of the earth. Okay, so you can see in the picture. So these are kind of a very undulations or the bends or these curvatures that are forming on the surface of the rock. Okay, so and these falls, these are happening at the deep underground, where the rocks are under very pressure and temperatures are very high. Okay, so this is the picture of a fold. So, and the process of development of folds, it is known as your folding. So next is your, what are the parts of a fold? So these parts are like, there are limbs or hinge. Okay, then again there are axial surface, axis of fold, flange of fold. Okay, so there are many. So limbs, you can say that these are sides of a fold. Basic, in simple words, you can say the limbs are the sides of a fold. Then hinge, you can say that it is a point where like the curvature is maximum, and then one limb it ends and the other limb it starts from that point. So that point is known as your hinge point, And if I say a hinge line, then when this rock it occurs in a sequence way, and there all the hinge points they are joined together, so that is known as your hinge line. Okay, and axial surface and axial plane, these are like axial surface is like it is a stack of folds that are passes through this hinge line, and they mostly they are nearly divide the folds into equal parts. Okay, that is your axial part. And if the axial surface it is not curved, then it is known as your axial plane. So next is your axis of fold. So axis of the fold, it is the intersection of the axial plane with one of the strata of which the fold is composed. Then comes your plunge of the fold. So plunge of the fold, you can define it as the angle of this inclination of the fold axis with the horizontal as measured in a vertical plane. That is your plunge of a fold. Then your next one is your crest and trough. So crest, these folds, they are of many variations, and they can be of two forms. That is your one can be at the upward, and the next one it has a downward bend. Okay, so the line that is running through these highest points in an upward fold, it is known as your crest, and the lower one is known as your trough. Okay, so this upper one, it is known as your crest, and the lower one is known as your trough. Okay, so next comes your classification of folds. I don't think there will be time for discussing this. The meeting will end in 2 to 3 minutes. Okay, let me complete till where I can. Okay, till then you please fill up the attendance form. Okay. So classification of folds. So there are two kinds of classification of folds. Uh, the number one is your anticlines, and the next one is your synclines. So these anticlines, you can define it as the strata that are uparched. Okay, that is they are convex upwards. So the here the leaves they dip away from each other at the crest. Okay, and syncline is just the opposite or the reverse, that this is the strata that are down arched, and these are convex downwards, and the leaves they dip towards a common center. So in this diagram you can see these are anticlines and these are synclines. Okay, that downward part is your synclines. Next is your symmetrical, on the basis of your position of these axial planes also, these folds can be divided into many kinds. So number one is your symmetrical folds. So the symmetrical folds is one in which the axial plane is vertical, okay, and